Today's modern industrial control systems are being delivered to asset operators with a multitude of features and functions they may never actually utilize, causing many organizations to take on unnecessary risk without any real reward. That risk comes in the form of an increased attack surface, as well as opportunities for failure due to the complexity of the system's design. This is where the concept of design simplification comes in. Design simplification is rooted in the idea that complexity creates risk, and the goal of this concept is to reduce that complexity in the system's architecture while still maintaining the system's intended function. Furthermore, as systems evolve over time, they naturally become even more complex with new integrations, use cases, and product swaps, increasing the need for simplified designs from the onset in a concerted effort to maintain that simplicity over time. For asset owner-operators, reducing the digital footprint of the products and systems they use and integrating only those features utilized in their operation is an obvious choice. However, the nature in which products are designed and sold to operators is in direct opposition to that ethos. In an ideal scenario, every component, exposed service, asset, and element of a system would have a discrete business requirement. If one could not be determined, it probably is not needed and should be eliminated from the design. By standardizing on a smaller set of vendors and products, we would be able to establish a slimmed-down base for system implementation. But there are simple and valuable steps we can take to reduce our security exposure from system complexity. As a practical solution, opportunities such as modular design and engineering out dependencies when possible not only expand security, but dramatically improves the ability to perform maintenance quickly and cheaply. The option to choose standard configurations as opposed to customization is another effective strategy, as custom usually implies one-off software development, which tends to be less mature and secure. Additionally, as many incidents are the result of human error, limiting the need for human interaction in the process can prevent avoidable incidents. While human operators are likely required to execute manual engineered controls, such as an emergency stop, normal operations can and should be as automated as possible. Finally, compartmentalization of functions can reduce the consequences of failure and limit cascading effects, such as network segmentation limiting impact to just the affected network segment and creating obstacles for the adversaries who do gain access. This concept can also mitigate software vulnerabilities, for instance, by handling data differently than code to reduce the ability for untrusted inputs to impact running software. Design simplification offers a solution to complex systems creating unnecessary risk and can assist many asset owners in their ongoing efforts to maintain system integrity and operational security. Contact us today to learn more about cyber-informed engineering and see how OpsRite is helping other critical infrastructure organizations secure their plant using the OpsRite Impact platform to deliver secure engineering by design.